Hello everyone, welcome to my channel. So in this video, I will share you my approach of the round 1 of the Data Science Student Championship that was organized by Machinehack and Praxis Business School. So this was the page of that particular hackathon and 827 registration was there and I ranked first in the first round of the leaderboard. So coming to the problem statement, so it was a regression problem where we have to predict the total share of taxi services, and the public leaderboard was on 30% of the test data, and the target matrix was RMSLE, that is mean squared log error. So coming to the data description, so there are only a few columns are there. So this total fare of our target, and which can be derived by adding this fare, tip, and miscellaneous fee. And these tip and miscellaneous fees are present in both test and test data. So what we have to do, we have to predict on the fare, and we just have to add this tip and miscellaneous fees with there. And apart from these three columns, there are only five columns present there, that is trip duration, distance travel, number of passengers, fare, that is our going to be our target, and the surge applied. So except this target and this miscellaneous fees and tip columns, only four features are there. So coming to the data part, so this train data has around 2 lakhs of observation, and the test data has around 90,000 of observation. And if we just have a look at the statistics of the data, we can clearly see that the distance travels column had some seriously high maximum value, where the mean is only 5 and um, the median is only 3.2. So that we will take care later. So coming to the ED of the target column, so if we plot the target, we can see it is highly skewed towards the left side, and what I also noticed that it has around a skewness of 8 point something and kurtosis of around 200 plus. So this kind of target is not captured by the machine learning algorithms well. So what I did a log transformation of my target. So just because there are so many zeros also in this fare, and we cannot take log of the zeros, so I added one before taking the log, and now we can see that the target is very much normally distributed, which should be better for our machine learning algorithms. Now, one thing I want to mention here that our evaluation matrix was root RMLSC. So just because I have already taken the log, so now I will update my evaluation matrix to RMSC. Now coming to this number of passengers column, so here I can see that it has integer value between 0 to 9, and out of them this 7, 8 has 9 has only very negligible values. So what I did is just to reduce the number of distinct passenger count, I replaced everything greater than 6 with 6. Here are the similar description of the test data. Here I can also see this. There is a some high outliers for the distance travel. So it is not like that. I did not took some other approach. I tried to the binning also, but in this video I am going to share with my final approach because I discarded all the unnecessary things to keep my video short and my notebook clean. So just because we have very less number of columns, I have created a feature that is named speed. So just there are few trip duration that was 0. So to get rid of this, I replaced whenever trip duration 0 is 0, and whenever trip duration is not 0, it is the ratio of distance travel and trip duration. So now here I did a scatter plot between trip duration and fare. You can see slightly linear relationship between this trip duration and fare, though it is not prominent. But one thing to mention that this is the log of the fare. Now coming to the distance travels part, so here we can see there are some seriously high outliers after 50,000, whereas most of the data are within 500. So what I did, I replaced everything greater than 500 with 3.5. So it is not a genuine outlier, because what I actually did was I filtered out only these outliers to check the target. So not only they have high distance traveled, they don't have the high target value also. So maybe this was caused by some error while entering the data. That should be something 50 point something or 5 point something. So I replaced with 3.5, which is slightly higher than the median. Now coming to the number of passengers part, we can see that this whenever number of passenger, so the data is widely spread. So maybe there is a high possibility that this number of passengers one can be mixed up the taxi fare and the cab fare. But I also try to create a separate column to identify this whenever the number of passenger is one. But finally I dropped that column because it was reducing my cross validation score. Here is the box plot of the previous column. Here you can see that how widely spread this number of passenger one is. The surge applied has only two values, 0 and 1. This is a boolean column, and we can directly fit it in our regression. So I tried to capture some relation between trip duration and distance travels, but what seems like that there is a slightly linear relationship towards the below part of this trip duration and distance travel, but there is not any prominent thing from which I can create a feature. Now coming to the data type and null value part, so there is no missing values in the data, so there is no need of cleaning that. Okay, now I have already replaced whatever greater than 500, so you cannot see here, but because I replaced for both train and test. Now coming to the correlation metric part, so here from we can observe that this distance travels at high correlation with fare log, which is also pretty much obvious from the business problem we have. This speed have also some decent correlation, not very much, but at least 0.014. And these miscellaneous fees and tips are supposed to be add with the fare, but just because they both have a good correlation of with fare log and also helped me to improve my score, I kept both two columns as my feature. So here are my final features, and the target is the fare log. So for the model building part, I have used two algorithms. One is the cat boost and one is the light GBM. So this cat boost, the founder of the cat boost claims that they works really well with the default set of parameters, and which was obvious also because that when I applied this cat boost very first time, it totally took my score from around 2 and 3 of the leaderboard. And just to reduce this model stochasticity, because we have very less number of features and not very huge number of data, so I did a did training on the 10K fold. So what I did was, instead of training the model on the whole data set, I divided into 10 small part, and I took 9 part at a time to train my model. And also I choose a number of estimators as 10,000, and to prevent the overfitting I applied a early stopping of around 300. So you can see that the first fold stopped after 1500, the second fold stopped after 2100, and so on. And this learning rate was automatically adjusted by cat boost as it was expected. And after the training is done, I got a mean RMSE score of 0.151898. And if I plot the prediction of all the tenfolds here, I also a similar Gaussian like curve that we got in our earlier distribution. And the range was also almost same. And now instead of plotting only feature importance of the entire data. I plotted feature importance of each of the individual fold so that we get most uh, genuine conclusion of what which feature is more important. So here also in the cat boost I can see the distance travels is more important. Okay, the second model that I trained was LightGBM. So I took the help of Optuna to tune my parameters. I have commented this line now to save the notebook running time, because I have already noted the initial parameters like landing rate and depth. Here also I noticed that when I ran on 10,000 of iteration, even if I am using 300 early stopping down, it is still overfitting my model. So I trained this model on a lesser number of iterations that I also derived from this Optuna. Okay, and this estimator was 200, and also I applied some regularization parameters like reg lambda and reg alpha to prevent the overfitting. So now I did the similar approach again. I ran the entire model on 10-fold. Okay, just because I have only run on the 200 estimator, so there is no early stopping, and here I can get the mean RMS value 0.154717. So if you go to the leaderboard, so this was the earlier score that we used to, that was that we had access. Okay, that is the public leaderboard. But when I submitted, I think I got around 1.37 or 38 something. Okay, so both of did model well, and here are the similar feature importance and the prediction plot of it. Now to get my final prediction, what I did, I have predicted on 10 folds of light GBM and 10 folds of cat boost. So I took the sum of 20 fold and divided it and multiplied it with 0.05. So that is purely the average. I tried with the other weighted average also, like 0.75 and 0.25 of individual model. But what I found that the average is working best, and probably the reason is that although they both are the gradient boosting tree algorithms, they find the pattern in two different ways. So light GPM split the tree leaf wise, and cat boost split the tree depth wise. So that's why probably taking the average or taking care of both the patterns and give me a much better result. Now, these are the final approach that I am going to share. As I mentioned earlier, I have discarded all the unnecessary things, unnecessary ED, unnecessary modeling part to keep my notebook short, because what I feel that ultimately your performance is better. There is no point of uh, doing unnecessary experiment and building 10 or 20 models just for the sake of the interest. Just you can just one and two model with which is well tuned. If it is working better, I think you should stick with it. So that's all about the video. I hope you like this video. If you like it, you can subscribe to my channel. If you have any doubt, you can comment it, or comment in the under the comment section, or reach to me by LinkedIn. Thank you so much. We'll see you in the next video.